Alright, so now we're doing operations with polynomials in several variables. The first thing we're going to do is evaluate 2xy squared minus 4x cubed y plus 5 for x equals -1 and y equals -3. Now, what I like to do is use different color pens, highlighters, anything, so that I'm aware of plugging in x equals -1 only for the x's. I don't want to confuse those x and y's. And the same deal for the y's. I want y to be -3, so only for the y values do I want -3 to be plugged in. So what I'm going to do is rewrite this. I have 2. Going on between 2 and this x is multiplication, and y squared. So I'm writing parentheses for my x's and y's, and then I'll just plug these values in after I finish rewriting this. And then I have minus 4x cubed, and then y is hanging along at the end. Oops, I don't want actually to write y. I want to leave that blank. And plus 5. So now let me plug in. I have x is really -1. So for each x I see, I'm going to plug in a -1. And for each y we see, we're going to plug in a -3. And let's see how this goes. So once we've plugged in the values for x's and y's, we now have to go ahead and use order of operations. So parentheses first, well, I put the parentheses there to exaggerate the negatives and also what I'm plugging in for multiplication purposes or exponent purposes, and so they're not really needing any work done there. So the next step is exponents. We have -3 squared, which is +9, because a negative times a negative is a positive. We have -1 cubed, which is -1, because we have an odd exponent. So an odd for a negative stays negative, and 1 times 1 times 1 is still 1. Still have that -3 there, and then plus 5 at the end. After exponents have been satisfied, we multiply from left to right. So let's start here. We have 2 times -1 is -2, times 9 is -18. And let's do the next part. I'm going to include this negative with it. We have -4 times -1, which is +4, times -3 is -12. There's 3 negatives, so there's an odd number, so our answer is negative. And that plus 5 we're not messing with. It's still just plus 5. And now we just got to combine these. So we have -18 minus 12 gets us -30 plus 5, which gives us a lovely -25. And there's our answer. Now, this is just pretty much a repeat of all chapter 12, except with several variables. So now we had x and y instead of just one variable. The same thing's going to apply when we combine like terms. Instead of just a bunch of x's or just a bunch of y's, now we're going to have them next door to each other. So we have 7ab minus ab squared minus 2ab plus 5a squared b plus 4ab squared. And we have to combine like terms. Like terms still follow that we have same variable. And I'm sorry about variable being spelled raunchy. And then we also have to have same power or exponent. So I'm just going to start with the first one I see. I see AB. They have to be exactly like AB, where A's to the first and B's to the first, or else it's no good. They're not like terms otherwise. So let's look at this next guy. We have A to the first, that's a good start, but B's to the second. Nope, he's not a like term. Okay, continue on. Oh, this guy's exactly the same because he has A and B. This guy's not because he's A squared, so that breaks our pattern. We need A to the first, B to the first. Sure, it has B to the first, but it needs to be all the same or no good. And same deal with the last guy. So 7AB is the same as -2AB. It's like you had 7 abs at one point, you stopped working out, and you subtracted 2 abs. I don't know if that quite makes sense, but there we go. We have 5 ABs. Then we have AB squared. So the only person it can get along with is someone who looks exactly like him. AB squared. We have A squared, B. Well, that's not the same. It has to be AB squared. So no. Oh, here we go. AB squared. So we have -1 of AB squareds plus 4 AB squareds, which gives us +3 AB squareds. And then this last guy here didn't have any like terms, so we'll just leave him be, keep him along for the ride. Now, this is our answer. But as you're probably going, well, I remember there was some crazy thing about descending order you talked about before. And you'd be right, there is descending order we have to worry about. With several variables, our descending order is a little bit different. We still follow alphabetical order. Biggest degree goes down to the lowest degree. Constants are always last. But it operates a little bit differently. So let's see. A is definitely before B in the alphabet. And the highest degree is A squared. So 5a squared b comes first. Now the next part is a to the first and a to the first. And you don't know how to decide, well, who comes before the other. You might be thinking, well, it's descending order, so this one should come first. We should have b squared. And that's not the case. So when there's several variables where they're right next door to each other, we actually go in ascending order for the second variable. So the 5ab will come next, because he's to the first power. And then the 3ab squared will be last because it goes to higher. So see, we have the alphabetical, the A, his degree is 2, 1, 1. So it's descending order. And then for our second guy, his degree is 1, 1, 2. So he's in ascending order. And that's just the funky way we like to see it displayed. I would not get too worried about ascending order, because they're technically the same answer, because this is all addition and the order doesn't matter. So don't be panicked about it. If you can put it in descending order, go for it. If not, remember your final's multiple choice, so no issues. Let's go ahead and look at the next one. Let's see. Okay. We have where we're adding. And adding is pretty much just the same as what we did in 12.4, where we see if the parentheses are important. If they aren't, we drop them. And in addition, they tend to never be important, but let's just double check ourselves. If there's anything in the front, it needs to be distributed. Nothing there, no exponents, so these parentheses are not important. Let's go ahead and drop them. And then check for the next guy. He has nothing in the front except a positive 1, which doesn't change anything. No exponents, so we're good there. We can go ahead and drop them. And now all we have to do is combine like terms. So it's the same thing as before. We have x cubed y, so the only people we can get along with are x cubed y's. This is x squared, no good. This is x to the first, no good. X squared, x to the first. There's not even an x cubed in sight, so there's no way there's a x cubed y squared. So go ahead, just bring him down. He doesn't have any like terms. Move on to the next one. We have x squared y. So we need only x squared y. He's x to the first, no good. X squared y squared, well, he has the x squared, right? But the y's to the first and this guy's squared, so they're not the same. Oh, but the next guy, here we go. There's our winner. We have x squared y. And then the last one's no good. So let's see. We have negative 3x squared y plus 4x squared y. So we have a total of 1x squared y. And you don't need to write the 1 in the front. Alright, let's see our next guy. We got xy squared. This guy's no good. And then the last one's actually good. Remember, there's really a 1 out front here, so we have 1 minus 8 of those. So we have minus 7xy squareds. And then last but not least, we just have the x squared y squared, which has no other partners. Alright, so let's look at this guy. If you were crazy and you wanted to go ahead and put this into descending order, actually, we're doing pretty good so far. We have the 2x cubed y squared. X squared comes next. Now, this is x squared y, and this is x squared y squared. So, the x squared y actually goes first because the second guy will be in ascending order. And then last but not least, we have minus 7xy squared. It really isn't all that important. I think mathematicians will probably have to get over themselves eventually about this ascending descending order. It's useful when we have to factor But right now, we're not going to look at some things that are this ugly. So I wouldn't worry about it too much, okay? Let's go ahead. Let's actually see the same problem, but instead of them asking us to add, let's subtract. So the only difference is instead of a plus sign for this middle part, we're going to subtract. Now, because there's a subtraction sign, it makes these second parentheses very important, in which we have to distribute the negative to each term. So when we rewrite this, the first guy's parentheses are still not important to us, so just drop them. And we'll distribute the negative here, so we have negative 5 x squared y squared. Negative times a positive is a negative 4x squared y. And then a negative times a negative is a positive 8xy squared. And now we just get to combine like terms. We already know the x cubed y squared doesn't got anybody else, so we'll just leave them be. We'll look at the x squared y. And the only one who has that is over here. So we have negative 3 minus 4 gets us a negative 7x squared y. And let's look at the next guy. We have xy squared, in which we have an 8xy squared. So we really have one of these plus 8 of them gives us 9 of them. And then last but not least, the minus 5x squared y squared doesn't have any like terms, so he stays the same. So here's our answer. And you can put it in descending order if you want to. It really doesn't make a difference. So that's how we subtract. Let's go ahead and see how we multiply. It's going to be the same deal, in which we have a binomial times a binomial, so we FOIL. Now just remember, when we multiply, we just need the same base. We don't need the same power. Alright, now it might be confusing you, so let me go back. Remember, when we combine like terms, they need same variable, same power in order to combine. When we multiply, all we need is the same base. As long as they have the same base, they can combine. And I'm not sure if you can see that because my screen might have cut it off. So let's go ahead and see the first guy. We have xy squared times xy. So we have xy squared times xy. And I'm just writing it out so we can see it in bigger detail. Really, we have x times y squared times x times y. That's what's going on. And it's all multiplication. So we can change the order to how we see fit by commutative law. So we can switch the y squared and the x. And now we can multiply same bases together. X times x is really x squared. Y squared times y is really y cubed. Remember, there's a little 1 there. 2 plus 1 is 3. Alright, so we can't multiply x squared times y cubed any further. That's all we can do. They have to have the same base in order for us to continue on. So when we multiply our first terms, we get x squared y cubed. So I'm going to erase this. I'm going to write it down again. We have x squared y cubed. Now let's go ahead and do our outers. So we have xy squared times y squared. Well, there's no x's here, so we're just going to have one of those x's again. And y squared times y squared, well, same base, you add the exponents. 2 plus 2 is 4. And now we'll do our inside. Negative 3x times xy. Well, we have negative 3 times really a 1 here, which is still negative 3. X times x is x squared. And there's no y, so y just comes along for the ride. So we can only multiply same bases together. X's with x's, y's with y's, integers with integers. And then last but not least, we have negative 3x times y squared, which gets us negative 3xy squared. And now we just have to see if there's any like terms. If there is any, we have to combine them. Let's see, we have x squared y cubed, there's no others. We have xy to the 4th, no others. X squared y, So that's it. And you can put it into descending order if you feel like it, otherwise just leave it as is. And that's all that's new in this section. We just tossed in an extra variable. So until next time. Oops.